There we go. Okay. It's some dinner. So we factored out a 2. Now what do we have inside the brackets? A difference of squares, right? We have an x squared minus 49. So that thing should factor be x minus 7, x plus equals 0. We then use something that we call the zero product property. Once you're in factored form, you can look at each factor and try to figure out what value of x would make that factor equal 0. So in our case here, if x equals 7, we would make the first run in brackets equal to 0, and if x equals negative 7, we would make the second set of brackets equal to 0. So we would write our answer as x equals positive or negative 7. We wouldn't write it separated out like I did. I'm just making a point here. Yeah, Kills. Okay. Good question. So I've noticed even when you guys are working on this that people are getting confused right here. Because sometimes that affects things and sometimes it doesn't affect things. We need to figure out when it does and when it doesn't. So when you have a monomial out front, that's what this is. This 2 is a monomial. If it contains no variables, like this one does right here, there's no way I could make this monomial equal 0. If I change x to be anything, this monomial will always stay as 2. Now, if this monomial had been 2x, I could have then chosen an x value that would change this monomial to be 0. So if there's no variables here, there's no answer for this factor. If there is a variable in here, then there is an answer. Does that help a little bit? That makes a little bit of sense. If it said like 2x here, then I'd have to add an answer. Because there's no variable in there, there's nothing that's going to affect it. 2y would work too, right? If it's 2 in any variable, it would make a difference. If it was 2y, then if y equaled 0, it would make everything 0. Yeah. All right, middle one. How am I going to solve that thing? Factor it. Always try to factor. Right, so we're going to diamond method this thing. When we diamond it, we're trying to multiply to be 6, add to be negative 5. We're going to do negative 3 and negative 2. If you see anybody in Math 10C, please tell them how important factoring is. So we factored that thing to become these two binomials. Now we actually have to solve them. So what could x equal to solve this quadratic? It could equal 3, because that would make the first thing 0. Or it could equal 2, because that would make the second one 0. I'm going to put that in a box. Hello.
So does that mean that if you put that 3 into that equation, like
If you put that
yeah,
all the way back into here and to here,
it would make 0.
it would make 0.
And same with the 2.
Same with the 2. So if I put 3 in here, 3 squared is 9, minus 15 is negative 6, plus 6 would be 0. So it would work. Yeah. So this thing solves the very original equation. Yeah. I don't think you have to. You should be able to. All right, third one. How are we going to try to solve that thing? We're going to try to diamond method it. Things that multiply to 1 and add to 6. No way that's going to work out for us, is it? Yeah, nothing works there. So if it doesn't work, we need a new solution to this question. We're going to use the box method. And after today, you're going to have a third method called quadratic equation. That's to get this thing up. Review of box method. You draw a beautiful little box right below your quadratic. Our goal of the box is to create a side and a top that are the exact same. Right? We're creating a perfect square trinomial. we look at what we have, and we know the only way to get x squared is if we had x and x. That's going to give us our middle of an x squared. We then look at our middle term, and we know we somehow want to add our two terms to get to 6x. What two numbers that are the same could add to get 6x? 3 and 3. And if you remember, it just was always that middle term divided by 2. So 3 and 3 would work out. We now fill in the rest of our box, just like an area diagram. So we have 3x, 3x, and 9. Most of us got really good at making those boxes. Where we got a little bit lost was what to do once we were here. You want to look at where you started. So what was the c value you started with? 1. We started with 1. We wanted to somehow become 9. What number do we have to add to 1 to get to 9 kilos? So we add 8 to both sides of our equation. By adding 8 to both sides of the equation, we turn our original quadratic into this perfect square trinomial. It's x plus 3 times x plus 3. So we write it like that. And now instead of being equal to 0, it's equal to 8. This is a situation you can all solve. We solved a whole bunch of them at the start of 2.3 as a class. What's the first step to solving this thing? Square root both sides. When I square root things, what do I have to put in front of it? A positive or negative. So I have x plus 3 equals positive or negative root 8. Then what do I need to do? Subtract 3 from both sides.
Plus minus.
Yeah.
Like get the entire thing off.
Yeah. If that was an option, like if this was one option on the test, and another option was this, but with only the positive or only the negative,
I mean, like
on a quiz, probably take away for sure at least some marks. Because what you've done is you've given me one answer, when really there's two completely different answers. So x equals positive or negative root 8 minus 3. That's a great answer for what we want to do right now. If this was a test, what's the last step I should do? Yes, yeah. You got to reduce root 8. So a better answer here would be x equals positive or negative 2 root 2 minus 3. That would be a better answer than this thing right here. And the reason being it's most simplified. Yeah, for sure. So if you went minus 3 plus or minus root 2 root 2, yeah, that would be perfect. In fact, that's the better way to write it. Yeah, so I would agree with that. Those are the three ways that we've seen so far: factoring, then diamond method factoring, and then box method. Today, we're going to learn the quadratic formula. The quadratic formula works for everything. Right? That's kind of a perk of it. Just like the box method, the quadratic formula will work for any quadratic equation I give you in this class. The quadratic formula depends on you being in your general form. Remember, your general form was 8x squared plus bx plus c equals 0. You must be in that form. If it's equal to anything other than 0, it doesn't work. They've given us a question. It says we could use completing the square, factoring, or the quadratic formula to solve the following equation. They give it to you right here. If we chose to solve that thing right now, we could diamond it, and it would become x minus 1, x plus So if we were to factor that thing, that's what it becomes. That means our answers would be x equals 1 and negative 4. So I'm just proving you we know the answer to this thing. The quadratic formula is right here. It will always be given to you. Okay, so you'll always have it on a formula sheet. You do not need to memorize it. It's x equals negative b plus or minus the root of b squared minus 4ac all divided by 2. There's a nice little song that goes with it. I think if you were in Miss Tuck's class, did she play that song for you? No? No. Did you? Huh? Yeah, that makes sense. I know it would. I don't know. Maybe she did. Maybe she didn't. Maybe she showed it on a day when you weren't there. Maybe she showed it. Maybe to only her favorite students. Yeah, it's that super bad song. Soldier Boy, yeah. Yeah, some like people like it was a class project. You had to remake a song so that it told you what this formula was. And a group of high school students, I don't have to. Somebody else. I don't know what it is. If I knew what it was, I'd tell you. Wow. Anyways, they had to memorize the quadratic formula. I'm not going to make you memorize the quadratic formula. I'm always going to give it to you. You'll always have it. The letters A, B, and C, they come directly out of your quadratic. So in our case, we had A right here, B right here, C right there. A, B, C. And if you were to take each one of those values and put it into this formula, it would give you the solutions for this quadratic without having to use box method, without having to factor. We're going to try it as a group. I'm going to show you how I do it. So it's kind of a slower method. Some people can throw this whole thing in their calculator every time with consistency and always get it right. Other people like myself, whenever we try to do it all at once, we somehow screw something up and it always spits out the wrong answer. So what I do is I go really slow and I show you my steps. First step is I'm going to replace every variable with a number from my quadratic. So that's going to be x equals negative b. So I'm going to go negative bracket 2. And every time I replace something, I'm going to put a bracket. Because it's going to help me keep all my negatives in check. Then it's plus or minus the square root of b squared, 2 squared, minus 4 times a, 1, times c, negative 3. All divided by 2 times 3. Oh yeah, I could do that. Actually works out better for me because we can run out of space. So you'll see anywhere I saw a letter, I changed it with the number that it connected with. Now, when I'm doing this calculation, like I said, I take my time. So, x equals this negative and then bracket 2 bracket, that's just negative 2. So now the bracket's gone. Plus or minus the square root. This thing underneath the square root sign, I'm going to calculate that. So I'm going to go 2 squared minus 4 times 1 times negative 3. I'm going to put that in my calculator. But I'm just doing what's underneath the root sign. Make sure you use brackets. Make sure you include all of your negatives. If you do this properly, you should get 4 plus 12. It should be 16. Right, you're minusing a negative. So if you use your calculator, that's going to change it to a positive. That's why I use brackets. That's why I go slow. So then I don't screw up on my negatives. All divided by 2 times an a, just 2. The next thing I do is I look at my square root. If it's a perfect square root, I definitely calculate it. Do we know what the square root of 4 is, or 16 is?
4.
Spoiler alert. So, x equals negative 2 plus or minus 4 divided by 2. The square root of 16 is 4. At this point, I have two solutions. I have the positive solution and I have the negative solution. So if I did negative 2 plus 4 divided by 2, that would be different than if I did negative 2 minus 4 divided by 2. Both answers are going to be right, but they're different answers. You could. Then you have negative 1 plus or minus 2, and that would work. It'd be the exact same. We calculate this one, we get x equals 1. Calculate this one, we get x equals negative 3. Which is the exact same answer as what we got when we factored. So we're just proving, hey, that actually did work. This quadratic formula will always work, which is kind of the big perk of it. It's also a lot more straightforward and easier than the box method, right? If you look at that thing, I'm just taking numbers and plugging them in and calculating them. Really simple, but you've got to take your time and not screw things up. It also works with everything. Like any situation, it'll get you out of it. That's kind of the nice thing about quadratic formula. I know teachers who only teach quadratic formula because they're like, works for everything. What else do you need? The problem is you need factoring skills for later on in your math life, so it's good to develop them more in grade 11, and you need the box method for something else you learn later on. So you're just getting some extra practice before you can hit this. I'll tell you now that on your test, you'll be able to use whatever method you want most of the time, but on your unit test, we have ways of making sure you understand what the quadratic formula is. So you remember those questions where it's like, Johnny does a question, and where's his mistake? So you're going to have one like that where little Johnny does the quadratic formula, and you're going to have to see, oh, where did he screw up? So if you had no idea what the quadratic formula was, you would be probably pretty hooped on that question. Same thing with factoring, right? So we have ways of making sure you know all these things. So don't get dependent on just one or the other, but know that you can use it for any situation. All right, I'm going to write the quadratic formula on the side over here. 4 x equals negative b plus or minus the root of b squared minus 4ac all divided by 2. You have two questions here. We want to solve them both. You can solve them using the quadratic formula. So I'm going to label out which one's A, which one's B, which one's C. That always helps me. I'm then going to plug them into my formula. I'm going to have x equals negative b, so negative bracket 4 bracket, plus or minus square root of b squared. I'm putting that b in brackets. So it's 4 squared minus 4ac all divided by 2a. So that's my first step. I'm showing every single thing that I substituted in there. I used brackets for every single letter that I substituted into that formula. And now I'm going to calculate just what's underneath the roots. So it's going to change to become x equals negative 4 plus or minus root. I'm calculating what's underneath the square root sign. 4 squared is 16 plus 4 more is 20. Divide by 2. Anybody have any questions up to this point? Yes.
Why is it plus? Why is it plus?
Because it's a negative and a negative.
Oh.
And that'll change it to a positive. Good question. We're good. Any questions up to this point? Yeah. Yeah, same thing. Cameron, so we're good. Okay, so if you look at this thing, can we do the square root of 20? No, we can't, right? That's going to be an irrational number. But we can simplify it. So the square root of 20 should break down to become 2 root 5. So we're going to simplify this thing. We have x equals negative 4 plus or minus 2 root 5, all divided by 2. This is fantastic. We've done a good job. But there's one last step. And that one last step is you're going to look at all the coefficients that we have here, each term. And you're going to notice that they are all common factors of each other. What can all three of those things underlined in blue be divided by?
2.
They can all be divided by 2. So we need to divide all of these by 2. That's going to change your final answer to become negative 4 plus or minus root 5. And that is exactly how I would want it to be answered. I don't want you changing that thing into a decimal. If you change it into a decimal, all you're doing is creating a more confused, negative 2 plus or minus root 5. Negative 2 plus or minus root 5. We have to take that 2 out of all three things. This is a perfect answer. This is what's known as an exact answer. There was no rounding there. That is your solution to this quadrant. Any questions? Because that's a new step that we haven't seen before.
So you don't have to show that we did anything with 2. That's fine.
Nope. We just simply divided that 2 into both terms. Probably good? Mm-hmm. Don't have to go any further than that. Yeah, that's how we show what x is equal to. Yeah. Kids.
Divide them all by 2.
Yep.
And shouldn't there be another negative 2 well, student mistake, I forgot.
Oh, on the bottom. Yeah. You could have put divide by 1, but don't need to. Maybe you got a question? Multiply everything else by 2? Because we took it out, right? Okay, I see what you're saying. I think I see where people are getting lost. So what we did here is we didn't divide out a 2. Like, we didn't factor out a 2. We literally have a division question. So that 2 is literally being divided into both terms. So we were to write this thing on the sideboard. Sorry, you video people. If you had this, you could break it up. Like that. Like this and this are the same thing. You could simplify that, right? That's equal to negative 2. You can simplify that. That's equal to plus or minus root 5. So we don't have to show that we took a 2 out anywhere. What we did was we actually divided each term by 2.
Does your root 5 just not get affected?
Right, because root 5s can't be connected with just constants, like just the coefficient. All right, we're going to do another one together. So my first step is I'm going to identify my A, B, C side. A, B, C. That helps me just identify what needs to go where in my quadratic formula. I then am going to change colors of my pen so it doesn't blend in with the other question. I'm going to change all the variables in my formula to become the numbers that I got from my quadratic. So I need negative b, negative bracket negative 1. There's no number in front of that x. but there is a negative sign, so that it's a negative 1. That's your b value.
So it's a negative.
Yeah, and so we're going to have to fix that on our next step. B squared, negative 1 squared, minus 4 times A times C. All divided by 2A. You'll notice I use brackets for everything. The A is down. Those brackets are more important than you think. Not just spending time putting them in and talking about them, just because. They do matter. Yeah?
Do we write the brackets because that's how we write it?
I would. It just helps you remember, like, I need those brackets. My next step is I'm going to simplify everything. So x equals negative 1 is going to be positive 1. Plus or minus the root. If you didn't put brackets and you used your calculator to figure out what went underneath the root sign, you would get it wrong. If you use brackets, you'll get it right. This negative 1 in brackets squared has to be in brackets. If you do your calculator and you do negative 1 squared without brackets, it tells you it's equal to negative 1. If you do negative 1 squared using brackets, it tells you it's equal to positive 1. You definitely want it to be equal to positive 1. So those brackets matter. So it'll change to 1 minus 4 times 4 is 16, so you get negative 15.
I thought there could be a negative after that.
Good point. So just to finish, we're at 2 on the bottom. Now, Lexi brings up a fantastic point. So we got negative 15 here, under the root sign. Are you allowed negatives under the root signs? No, we've run into this problem before, haven't we? What happens if you have a negative under the root sign? It means there's no solutions. So if you have a negative underneath the root sign, that's not possible. So that means there's no value of x that would make this thing work. That means there is no solution. It's not possible. Anybody have any questions about that? Yeah.
When I put all that underneath the sign, I got a not real answer.
Yeah, that would be a no solution. So
Oh, that's why.
that's why.
Okay.
Yeah, because you're trying to square root a negative. Yeah. If your calculator says no real answer, and that's what it says, right? It says no real answer. Yeah, that means you square rooted a negative somewhere, or you divide it by 0 somewhere.
So to find out the answer, without getting my head, would I just Google out the square root and
They're literally.
just put it on paper?
Oh yeah, I would do exactly what I've done here. Show, hey, I'm dividing by 0, or I'm square rooting a negative. That's not allowed. That means no solutions. That's how I would prove my answer. So on a quiz, if that were to pop up and you just wrote no solutions, you need evidence of no solutions. That's where it would be. All right, 2 questions for you guys to try. So you can solve these using whatever strategy you please. It's not telling you have to do one or the other. It's telling you to do anything you want. Yeah, you may. Factor that first one. So I had to choose quadratic formula or box method. No choice. If I tried factoring it, it doesn't work. If you did box method or quadratic formula, make sure you remember to reduce your square root, right? Reduce that radical, and then divide out a 2 at the end. If you did number 2, you could have done any of your 3 methods. You could have factored, boxed, or done quadratic formula. Factoring is a heck of a lot faster, much more neat, much easier. So I factored. Like I said, anytime you can factor, that's usually the better, easier option. You guys are better at factoring than you are at anything else. Trust me. Alan.
Can you write down that 40
You'll have that formula for everything. Yeah, I'll definitely write it down for you. Yeah. If I forget, just let me know. But I'll definitely have it written down for you guys.
Do you have to memorize it for the final exam?
No, you will always have the quadratic formula. I keep saying it.
Just making sure.
Yeah, I'm not gonna switch it up on you guys. You'll always have it. Promise. Promise. Just what's underneath. Yeah, don't put the square roots on it. Yeah. Sure.
Okay, if you're gonna give us the quadratic formula, this might sound like be a little, I don't know. Then why can't you give us a square root sheet?
Oh, jeez. Do you want me to take away the quadratic formula?
No.
Because that's the option. You can memorize the quadratic formula too. I'm okay with that. Mike, stop. Here's my reason.
Stop there. Okay, I'll be quiet.
This thing. If you didn't have it memorized, is there any way you could figure it out? If you don't have the square root sign, the perfect squares memorized, is there a way you can figure it out?
Yeah.
That's all. You could figure it out, right? If you don't know them off by heart, you could at least figure it out. You could not figure this thing out. I don't see anyone in this room figuring that out consistently. If you could, it's just gonna be luck. Okay. I think you were about to get involved there. Okay. You guys good or what? I'm trying to keep going. But you've just touched the top of the quadratic formula. Alright, we got 2 more questions here. If you look at these things, that is a quadratic. That cannot be solved right now. Why can that thing not be solved right now? What is it, Brahma? Doesn't equal 0. You have to have things in equal 0 form. If you don't, then you need to expand it all and move it all over. So this thing has to be adjusted before we can even start solving it. So I'm going to multiply that 3 into the brackets. So I have 2x equals 3x squared minus 3. And I'm going to subtract 2x from both sides. Notice when I subtract 2x from both sides, I'm putting it in as my second term. I'm writing it in descending order, right? So the highest exponent goes first, and then next exponent, and then no exponents. You've got to convert these things, or else you can't solve them. Must equal 0, must look like this, a, b, c equals 0. If it's 0 equals, then ax squared plus bx plus c, that's okay. If you want to use quadratic formula, it doesn't matter what your a value is. If you want to use box method, your a value matters. And if you want to factor, your a value matters. Remember, box method didn't work unless this was a perfect square number. We always needed that 3 to be a perfect square number. Factoring doesn't work unless this is a positive number. Okay, so in this case right now, we couldn't box method that without altering it a little bit. We could try to factor it, or we could use quadratic formula on it. If we tried to factor it, we'd be multiplying to -9, adding to -2. Nothing's going to work for that. So we have to use quadratic formula, or we have to change it, make it box method. I think at this point, that's a really tough box method question. So I don't want to box method this. Instead, I'm going to use quadratic formula. When I put it all in, you guys have seen this before. I'm going to use brackets. Plus or minus the root of b squared minus 4ac. Small divided by 2a. I'm going to do this kind of quick, so we're not going to write it out as much. So if you do this thing, you're going to get x equals 2. If you multiply these together, You're going to have 4 times 9. 3 times 3 is 9, which should be negative 9. And you're going to get 36. So 4 plus 36 gives us root 40, all divided by 6. Why is that answer not good enough right now? You can simplify that thing, right? That square root of 40 can be simplified. When you simplify it, you're going to break it down to be 4 and 10. Just type this up so you can see it. And you have x equals 2 plus or minus 2 root 10 divided by 6. Okay, we're at another new situation for us. Before, when we were looking at these quadratics, we were able to divide this bottom term into the other ones. In this case, we're not able to. 6 doesn't divide into 2, and 6 does not divide into 2. But there is a number that divides into all 3 of them. What is it, Cameron? A 2 could divide into all of these coefficients. So if all of these things are divisible by the same number, you divide them. It's like simplifying a fraction. That's all you're doing. So it becomes x equals. What's 2 divided by 2? It's 1. How many people I could have promised you would have put 0? And remember that there has to be a 1 there. 2 divided by 2 is 1. It doesn't cancel each other out. Root 10 divided by... That's a perfect answer. That's exact form. All right, we're going to do B. Unless there's any questions on A. If we move on to B, we look at this thing. Why is that not something I can solve right now?
Fraction.
Fractions make it suck. Why else? Not equal to 0. You gotta be equal to 0. You have to be. To make this thing equal to 0, I'm going to subtract 5 over 6x from both sides. So I'm going to have 2 over 3x squared minus 5 over 6x minus 1 equals 0. Alright, another point came up that was good. If I want to factor this thing, which that's always the thing I want to resort to. I always want to factor these things. I can't because of those fractions. If I want to do box method, I couldn't because I had these fractions. So how can I get rid of a fraction? By multiplying. Some of you guys are mouthing it out. It's by multiplication. What number can I multiply these things by that would get rid of my fractions for me? 6. If I multiply everything by 6, all my fractions will go away. Now, we also have to multiply that 0 by 6. Because what you do to one side, you do to the other. Remember how we said earlier in the unit, when we were fixing these fractions, how we had to balance it out? We had to put that 1 over 6 out front? We don't have to do that this time because we balanced it out by multiplying the other side by 6. So that's your balancing it. But you always have to do something to balance both sides of an equation. This thing changes to become 4x squared. If you're not sure why it became 4, 6 times 2 divided by 3 is equal to 4. Use your calculator and trust yourself on that. The 6 divided by 3 is 2. 2 remains times by the other 2. Minus 5x minus 6 equals. Now we can solve that thing. What's 0 times 6? 0, yeah. Sorry, I just kind of glanced over that. 0 times 6 is still 0. So even though you balanced it, you really didn't do much. If I tried to factor that thing, I want things that multiply to be negative 24 and add to be negative 5. Eight and 3 would work. 8, 16, 24. So if you had negative 8, positive 3, you could factor that thing. If you looked at that and were like, I can't figure it out, what methods could you use? quadratic formula or box method. But because we can diamond this thing, I'm definitely going to rely on that. Because my skills here are more refined. I'm just better at it. Remember when you're factoring and there's an a value, I need to represent that a value somewhere in here. So I go 4x minus 8 and 4x plus 3. I definitely didn't want 4x twice, did I? So what do I have to do? Got to divide one of them by 4. This first one divides by 4 beautifully. So we got x minus 2, 4x plus 3 equals 0. On your quiz tomorrow, a lot of you guys will get to that point and then you'll stop. All you've done is factor. Have you solved this quadratic?
No.
No. Solving a quadratic means at some point you wrote x equals, here's a number, here's a number. X equals positive 2 from the first set of brackets. And from the second set of brackets, because it's an addition, then I need a negative. And it's always going to be a constant divided by the coefficient. So negative 3 divided by 4. That's solving the quadratic. That's answering the question. Yeah, Kyle. For sure.
How did you get that 2 over 3?
Trying to get,
Like a 6.
I put 2 over 3 in my calculator in brackets, and it times it by 6. 2 divided by 3 in brackets times 6. And it'll come out to be 4. Alright. We have 2 beautiful word problems here. You're definitely going to have word problems on your test, on your unit test, and it's definitely going to be the place that we struggle the most. Unit 3 is also going to have a bunch of word problems. And those word problems are definitely going to be where you struggle the most. On Wednesday, we are going to practice only word problems because it's what's going to be on your test and it's where you're going to struggle the most. So, my strategy for word problems is always going to be to read it once, let yourself digest the question a little bit, read it again, and start marking down any information that you know and how you're going to tackle this thing. So if we read it once, it says the surface area, A, so surface area is represented by letter A, of a cone with radius R and slant height S is given by the formula, and then they give you a formula. A cone has a surface area of 300 centimeters squared and a slant height of 15 centimeters. What is the radius of the cone to the nearest hundredth of a centimeter? Sarah?
Isn't slant height just slope?
Sort of like slant height. So this is a cone. Here's my beautiful cone. Gorgeous, right? But height of this cone is measured from the very top to the very bottom. Slant height is measured from here to here. That's what they mean by slant height. It's the distance. It's not the the slope of it. It's the actual distance if you measure it out. Yeah. All right, we read it once. We're now going to read it again. It's going to help us out. So we know we got a cone, and we know they want us to figure out the radius. That's all we really know. Reading it the second time through lets us, okay, relax a little bit and write out information as we get it. So we got the surface area A of a cone with radius R and slant height S. So A means area, R means radius, height means S. That's all good info to know. The cone has a surface area of 300 centimeters, so A equals 300. I drop the units. I think the units just make things more confusing. So I say A equals 300. And a slant height of 15 centimeters. Well, that means S equals 15. what is the radius? So what is the radius? What does R equal? Question. Once I have all my info, I'm going to plug all my info in to whatever formula I might have. In our case, it's right here, so I have 300 equals pi. Do we know what R is? So pi R. We know what S is. S is 15. Plus pi R. We can put that all in. We look at it, and if this were me, this is my test. I'm looking at this thing and I'm going, I have no idea what in the heck R needs to be to solve that thing. I don't have a clue. What value of R is going to make this thing equal 300? Don't have a clue. But I do recognize that I have a quadratic. I have an R squared, I have an R, and then I have no R's. This thing's a quadratic. It's just not in a typical quadratic form that we're used to. So what we need to do is try to rearrange this into a situation we could solve. If we want to solve this thing, what do all quadratics have to equal? 0. So what do I need to do with this 300? I just subtract 300 from both sides. And when I do this, I'm also going to reorder my quadratic. So we're used to seeing it as x squared comes first, then your x, and then nothing. So I'm going to reorder this to be 0 equals pi r squared plus 15 pi r. Notice I also reordered that so that the coefficient came first. We're used to seeing things like that. And then minus 3. I think a lot of people can get to this first stage. I think a lot of people struggle jumping to this second stage. You're in the solving quadratics unit. $10 says every question's a quadratic. Right? That's probably a fair assessment of the situation. You're probably going to have a quadratic somewhere in here. So you got to recognize, okay, what's my squared variable? What's my non-squared variable? And then what's my constant? And try to set it up so that it's equal to 0, because that's the only way you can solve these things. And look at that. I want to try to solve that. I could try to factor it. If I try to factor it, my A value is pi. That's probably going to really suck. If I look at this and I'm like, well, I could try to box it, that A value of pi is really going to suck. So what would be a good method? The quadratic formula can handle pi. I mean, it's not going to be pretty, but it's going to work. Yeah.
Because the 15 is pi, wouldn't pi just be part of the r squares with like the wasn't that?
Good question. So, like, that's probably one of the biggest things people make a mistake on this question in particular, is they feel like pi is part of r. Right? It's like pi r. But really, this is a number. What number is this? 3.1415 goes on forever, right? So when it's 15 pi, it really means 15 times that number. So this isn't actually 15 and then pi r. This is really like 47, 48 point something, 47 point something crazy. So this is a number right here, and that is a number right there. Those are actual values. This is your A value. This is your B value. And this is your C value. Okay, so B value is 15. The B value is 15 pi. Pi is a number, it's not a variable.
So not r squared, it's pi squared.
Just pi, correct. So we try to solve this thing now. It's going to get a little messy on us. I'm going to put it up a little bit higher. No, my 300. Away. Alright. We're going to quadratic formula this thing. We're going to have x. If you put r equals, that works too. But I'm just calling r x because I'm just used to it, right? It's stuck in my brain. So, x or r equals negative b, so negative 15 pi, plus or minus the root b squared, 15 pi squared, minus 4a pi c, negative 300. All divided by 2. Alright, this is where things are going to get really fun. I told you, you got to simplify what's inside this radical. Then you got to try to simplify the radical. And then you're going to cancel things out to put it in its simplest, most beautiful form, correct? Alright, has anyone calculated 15 pi squared minus, okay, what number did you get?
5,990.
Right, so you're going to get a really ugly number under the square root, and it's going to be an irrational number. It's going to be a decimal, and it's going to go on forever. You're not going to be able to simplify that thing. So you get to that point, and some people might get here and be like, oh my god, I'm screwing up so bad because I don't know what's going on. But there is something that happened in this question that we never circled or underlined that was really important to us. And that part was to the nearest hundredth. That right there tells you, you don't need to simplify this thing down into its simplest form. You just need to calculate what this is. Now, if I were you, I would definitely take my time with it and not try to do this whole monster at once. What I would do is I would slowly break it down, just like we were before. If you do that number, I'm just going to confirm it with you. So we got 15 pi squared in brackets, so 15. My pi button is in here, don't use 3.14. Minus, then 4 pi times 300. I would do this calculation, like I would do the square root of that. Then I would do negative 15 plus or minus that, all divided by 2 pi. My question for you before you leave, am I going to need to do the positive or the negative version of this question? You could do both, but if I have a negative minus a number, I'm definitely going to have a negative. Would a negative slant height make sense?
No.
So you only need to do the positive, because that's the only answer that'll matter.